Dear student, today we will learn chapter number 3, Indices and Cube Root. If you have not subscribed my channel, please subscribe it today itself. Let's start. Let's recall about indices. The product 3 into 3 can be expressed as 3 raised to 2. You can see that just above 3 there is a number 2. So here 2 represent that how many times 3 is there in the product form. It's there 2 times, that's why it is 3 raised to 2. The product 3 into 3 can be expressed as 3 raised to 3. The product 3 into 3 into 3 into 3 can be expressed as 3 raised to 4. And the product 3 into 3 into 3 into 3 into 3 can be expressed as 3 raised to 5. The product 5 into 5 into 5 into 5 can be expressed as 5 raised to 4. You can see that 5 is 4 times in the multiplications. That's why you can see that there is a 4 just above the 5. 5 into 5 into 5 into 5 is known as product form, whereas 5 raised to 4 is known as index form of 5 into 5 into 5 into 5. Here 5 is known as base of the index form and 4 is known as index or power of the given index form. Let us see the meaning of indices in the form of rational numbers such as 1 upon 2, 1 upon 3, 1 upon 4, 1 upon 5 and so on, that is 1 upon n. So here these are the rational numbers, and now we will see that index form where the power is rational number. The square root of a number means the index is written as 1 upon 2. So what do you mean by the square root of a number? The number will have index as 1 upon 2. The fourth root of a number means the index is written as 1 upon 4. You can see that the numerator is same when the denominators are keep on changing as per the given root. For example, square root of 5 can be written as 5 raised to 1 upon 2, or it can also be written as root 5. You can see that there is one sign, inside the sign there is a 5 and the sign is represent radical sign. Fourth root of 5 can also be written as 5 raised to 1 upon 4, or it can also be written as cube root of 5. This sign, you can see there is some symbol, this is a radical sign. Now we will see practice at 3.1. Here we have main question 1, express the following numbers in index form. Here we have the first sum, fifth root of 13. You can see it is given root, right? That means the index of number 13 is a fraction, is a rational number. Okay, so what you can see there, fifth root, that means the denominator of that fraction would be 5, whereas the numerator will remain same, that is 1. So we can write this in index form like 13 raised to 1 upon 5. Okay, so numerator will remains 1 while denominator will keep on changing. Sixth root of 9, see it is given sixth, that means the denominator of the fraction would be 6, whereas the numerator will be 1. Therefore the answer is 9 raised to 1 upon 6. Square root of 256, square means second root of the given number. Okay, that means here the denominator of the fraction should be 2 and the numerator should be 1. Therefore, 256 raised to 1 upon 2. Cube root of 17. Cube means third root of 17. That means denominator should be 3 and numerator should be 1. Numerator will remain same, that is 1, only denominator will keep on changing. So we will write this as 17 raised to 1 upon 3. 8th root of 100, which we can write as 100 raised to 1 upon 8. 7th root of 30, we can write this 30 raised to 1 upon 7. We have now question number 2. Write in the form of nth root of a in each of the following numbers. Here we have the first index form, and this index form we will write as nth root of the given number. So what is the denominator of this fraction? It's 4. So it is fourth root of 81. Now here we have the next question. It is an index form of the next question. Look at the denominator of the given fraction. It's a 2. So you can say it is second root of 49, or you can also say it is a square root of 49. Now here we have the next question. Look at the denominator of the fraction. What it is? 5. So it is fifth root of 15. Look at the next question. What is the power of this? 1 upon 4. What is the denominator? Denominator is 4. So it is fourth root of 512. Now here we have the next question. Look at the denominator of this fraction. What it is? 19. So it is 19th root of 100. Now here the index is 1 upon 7. So what is denominator over here? 7. So it is 7th root of 6. Let us see the meaning of indices in the form of rational numbers, such as 5 upon 2, 2 upon 3, 5 upon 4, 4 upon 5. That is m upon n. Okay, you can see these all fractions are rational number. The most important is that the numerator of each fraction is other than 1. For example, here we have 10 raised to 2 upon 3, 5 raised to 7 upon 9, 3 raised to 3 upon 4. You can see that the index of each of the index form is rational number, where the numerator of each index form is other than 1. How to read the following index form? Let's example. Here we have the first question, 4 raised to 5 upon 7. Now let's see how to read this index form. The first way, you can write this fifth power of 7th root of 4. Look at the numerator of this fraction. What it is? 5. That 5 is what is power, and denominator is what you all know, it is a root. So denominator is root, whereas the numerator is power. So we can say it is a fifth power of 7th root of 4. You can also read this index form like this also, 7th root of 5th power of 4. Okay, you can say first power and then root, or you can say root and then power. This two way we can write this given index form. Let's see one more example. Here we have 10 raised to 2 upon 3. Okay, so what is the index over here? 2 upon 3. So what is the numerator of this fraction? 2, and denominator is 3. So denominator indicates root, third root, and numerator indicates power, second power, or you can say square. So we can read this as square of cube root of 10. You can also read this as cube root of square of 10. So you can read this kind of index form in two different ways. First power and then root, and the second time you can write root and then power. Now we will have practice set 3.2. Complete the following table. Here we have question number 1. 225 raised to 3 upon 2. Look at the third column, it is given power of the root. So first we will write the power and then we will write the root. Power should be in a numerator and root should be in a denominator of the index. So here it is, you can see in the numerator it is 3. So it is third power. You can also say it is a cube of second root or square root. Cube of square root of 225. Now we will write the same thing in different way. Root of the power. So which root you can see in this? It's a second root, square root. And which power? Third power, or you can say cube. So square root of cube of 225. Here we have the next question, 45 raised to 4 upon 5. So first we will write the power and then we will write the root. Which power you can see over here? What is there in the numerator? 4. So it's a fourth power. And which root? Fifth root. So we can write this fourth power of fifth root of 45. Now the same thing we will write in another way, root of the power. So which root? Fifth root. Which power? Fourth power. So fifth root of fourth power of 45. Now here we have the third one, 81 raised to 6 upon 7. So what is the power over here? Sixth power. And what is root over here? Seventh root. So it is sixth power of seventh root of 81, which you can also write as seventh root of sixth power of 81. Now here we have the next 100 raised to 4 upon 10. What is in the numerator? 4. So it is fourth power. And what is then in denominator? 10th. So denominator indicates root. So it is 10th root. So we can say that it is fourth power of 10th root of 100, which you can also write as 10th root of fourth power of 100. Now here we have the fifth one, 21 raised to 3 upon 7. So which power? Third power. Okay, third is also be known as cube. And what is root over here? Seventh root. So it is cube of seventh root of 21. Okay, which you can also write as seventh root of cube of 21. Write the following numbers in the form of rational indices. Square root of fifth power of 121. So now we have to write this statement in index form. Okay, so look at over here, what is the base of the index form? 121. And what would be the index of this number? It would be fraction. It would be fraction because it's a rational number. So in a fraction, denominator would be the root and numerator would be the power. So it would be 121 raised to 5 upon 2. You can see that 5 is indicates over here power, whereas the denominator indicates over here root. Cube of fourth root of 324. Okay, so which power? Third power, cube. So numerator would be 3. Fourth root, denominator would be 4. So it would be 324 raised to 3 upon 4. Now here we have fifth root of square of 264. So which root? Fifth root. So denominator would be 5. Square. Square means the power should be 2. Second power. So we will write this 264 raised to 2 upon 5. Cube of cube root of 3. What is the power over here? Cube. Cube means the power is 3. Third power is called as cube. Cube root. Cube root means third root. Third root means cube root. So here the index would be 3 upon 3. So here the index form is 3 raised to 3 upon 3. Cube and cube root. What do you mean by cube of a number? If a number is written 3 times and multiplied, then the product is called the cube of that number. Let's say example 4 into 4 into 4. You can see that 4 is written 3 times in the form of multiplications. Okay, so we will write this as 4 raised to 3, and the value of this is 64. So here 64 is called as cube of 4. 4 is cube root of 64. So 64 is cube of 4, whereas 4 is cube root of 64. 5 into 5 into 5 can be written as 5 raised to 3, which can be written as 125. So here cube of 5 is 125. Cube means if a number is taken, if any number is taken 3 times in a multiplication, the product obtained is known as cube of the number. So here 125 is cube of 5, whereas 5 is cube root of 125. Practice set 3.3. Find the cube root of the following numbers. Here we have the first question, 8000. So what is the first step? You need to find out prime factor of 8000. Okay, what we will find? Prime factors of 8000. Let's see how to find the prime factors of 8000. Okay, here we have 8000. Now we will divide 8000 by prime number. Okay, prime number means a number which is divisible by itself and 1, like 2, 3, 5, 7, 11, 13. These are the example of prime number. So what is the smallest prime number over here? 2. And you can see the last digit of the 8000 is 0, which is divisible by 2. So we will divide by 2. If we will divide 8000 by 2, we will get 4000. Now 4000 is divisible by 2. So we will divide this by 2. So when you will divide 4000 by 2, what you will get? 2000. 2000 is again divisible by 2. So we will divide 2000 by 2. We'll get 1000. We'll divide 1000 by 2. We will get 500. We will divide 500 by 2. We will get 250. We will divide 250 by 2. We will get 125. We will divide 125 by next prime number 5. We will get 25. We will divide 25 by 5. We will get 5. And we will divide 5 by 5. We will get here 1. So here we got a prime factors of 8000. Therefore 8000 can be written as 2 into 2 into 2 into 2 into 2 into 2 into 5 into 5 into 5. Okay, now we'll make a pair. We will make a pair of same 3 numbers. You can see I have made a pair of 2 into 2 into 2. It's one pair. Now this is 2 into 2 into 2 is the next pair, and 5 into 5 into 5 is the next pair. Therefore 8000 equals to 2 raised to 3 into 2 raised to 3 into 5 raised to 3. Correct? First group is 2 into 2 into 2, which you can write as 2 raised to 3. Second group is 2 into 2 into 2, which also you can write as 2 raised to 3. And third group is 5 into 5 into 5, which you can write as 5 raised to 3. Therefore 8000 equals to, you can see that the index of each of the index form is 3. So you can write this as 2 into 2 into 5 whole raised to 3. We will multiply the numbers which you can see in a bracket. We will get 8000 equals to 20 raised to 3. Therefore square root of 8000 equals to 20. Now here we have the next question, 729. We will find prime factor of 729. Let's see how to find the prime factor. We will divide 729 by 3. We will get 243. We will divide 243 by 3. We will get 81. We will divide 81 by 3. We will get 27. We will divide 27 by 3. We will get 9. We'll divide 9 by the 3, we will get 3, and then we will divide this 3 by 3, we will get here 1. So we got a prime factor of 729. Therefore 729 equals to 3 into 3 into 3 into 3 into 3 into 3. Now we will make a pair. We will make a group of 3 same numbers. Okay, so let's see here. 3 into 3 into 3 is one group, and 3 into 3 into 3 is the next group. Therefore 729 equals to 3 raised to 3 into 3 raised to 3, which you can also write as 729 equals to 3 into 3 whole raised to 3. Therefore 729 equals to 9 raised to 3. Okay, so 729 is cube of 9. It means cube root of 729 is 9. Now here we have the next question, 343. We will find prime factor of 343. Let's see how to find. 343 is divisible by 7. 7 49s is 343. We will divide 49 by 7. We will get here 7. 7 sevens are 49. Now we will divide this 7. We will get here 1. So we got a prime factor of 343. Therefore 343 can be written as 7 into 7 into 7. Now we will make a group of same three numbers. You can see there is only one group of 7. So we can write 343 equals to 7 raised to 3. So 343 is cube of 7. Therefore 7 is cube root of 343. Therefore the cube root of 343 equals to 7. Now here we have the next question, minus 512. Here also we have to find out cube root of this number. So first we will ignore negative sign. Okay, we will find the cube root of 512. So first we will find the prime factor of 512. We will divide this by 2. We will get 256. Divide 256 by 2, we will get 128. Divide 128 by 2, we will get 64. Divide 64 by 2, we will get 32. Divide 32 by 2, you will get 16. Divide 16 by 2, we will get 8. Divide 8 by 2, we will get 4. Divide 4 by 2, we will get 2. Divide 2 by 2, we will get here 1. So we got a prime factor of 512. Therefore 512 can be written as 2 into 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 2. How many times 2 we can see? 9 times, right? So 512. Okay, now we will make a pair. We will make a group of same three numbers. You can see 2 into 2 into 2 is one group, 2 into 2 into 2 is another group, and 2 into 2 into 2 is the last group. So 2 into 2 into 2, the first group you can write as 2 raised to 3, second group you can write as 2 raised to 3, and third group you can write as 2 raised to 3. So 512 equals to 2 into 2 into 2 into 2 raised to 3. Therefore 512 equals to 8 raised to 3. So 512 is cube of 8. It means cube root of 512 is 8. Therefore cube root of minus 512 is minus 8. Now we have the next question to simplify. Here we have the first question, cube root of 27 upon 125. Now what we will do here, we will find the prime factor of numerator and prime factor of denominator. That means prime factor of 27 and prime factor of 125. Let's see what we will get. 3 into 3 into 3 and 5 into 5 into 5. Now we will make a group of same three numbers. So numerator is group of 3 and denominator is group of 5. Okay, therefore cube root of 27 upon 125 equals to 3 upon 5. Now here we have the next question, cube root of 16 upon 54. We will find prime factor of numerator and prime factor of denominator. So numerator would be 2 into 2 into 2 into 2, and denominator would be 2 into 3 into 3 into 3. Now you can see that 2 from 1 2 from numerator and 1 2 from denominator will get cancelled. So we will get cube root of 2 into 2 into 2 upon 3 into 3 into 3, which you can also write as cube root of 16 upon 54 equals to 2 upon 3.